Hey, I was going to make a video about the Qt models and views and having multiple views work together or look at the same data in different ways. Before doing that, I think it's important to touch upon subclassing and classes in general. So far, I've kind of avoided talking about classes and object-oriented programming. And it's time to bite the bullet on that because we're kind of being confronted by Qt to understand this a little bit better. So, for example, I've got the documentation page here for the Q main window. And in this little diagram, what it tries to tell us is that the Q main window builds on top of Q widget, which builds on top of Q object and Q paint device. And then it lists all the functions that are added by Q main window on top of what is already there. And if we look at the C++ documentation, it's fairly similar in that it says what is being added, but it just written slightly differently in how the types look. And yeah, C++ has a few more symbols that we don't care about in Python. But what's cool about the C++ documentation is that you have this button, list of all members, including inherited members. And it shows the flat list of all the functionality that the Q main window has to offer, which is something not available in the Python documentation. So if you're looking for a function, this is where you want to be. And kind of to explain how this works and why the Q main window has all this extra functionality, I would like to demonstrate a really basic example where we just make a very simple class and then inherit that class again in just a standard Python example. So I'm just going to make a class called a positive number, for example. And to create a class, you need to create a function called _init, and then it gets this argument called self as the first argument. So this is just like any function, but it's indented inside of a class. And then self is a consistent reference. It's like when you create a list, that list knows about itself. When you call the append function of the list, it appends to that copy of the list or that version of the list, right? So when we're creating a positive number, that positive number knows about itself. So it can have a number, for example. Let's just make that an integer. And then I can have a number is going to be positive number. And then I can print number. And then I can run this piece of code. Well, that doesn't tell us very much. Sadly, displaying classes is not very clear. Like so far we've used floats and lists, and they all have very good ways of displaying themselves. For a class you would have to write that yourself, but I'm not gonna talk too much about that. So for now we can just access the members of the class. So we added something to self, and when we create a positive number, we can read from that copy of the number, much like when you create a Q widget, you can get information about that widget's position or its window title and those kind of things. So now it prints 0, which is indeed what was stored internally. And just to clarify, there can be two numbers, like I can make A and B. I can print the number of A and the number of B. And I can change the number of B to be 1. And just to show you, I create an A, which has its own number attached to self. And then I create a B, which has its own number attached to self. So when I change B, A doesn't change. Right, so there's just two numbers in here. And if you want something more analogous to how Python kind of works, like we could make two lists like this, right? They're both lists, but they have their own different contents. So that's how you should think about them. They're pieces of data that you can manipulate, and the data has a certain kind of feature set, and the class describes the feature set. So the list has, for example, an append function that is described by the class of the list. And we could add a function that calls increment, for example. And every function, again, gets this self, so we can always refer to our own internal data. So when the creation of the class attaches this number value, the increment function can access that number value, and it could do, for example, +=1 to increment it. So now if I say b.increment, that function now exists on every positive number, and b will be incremented by 1, a will still be the same. So that's kind of how a class works and how functions kind of interact with internal data. It is not much different from writing normal Python functions. You could think of it like this, for example. Create a number could be a function instead of an init, and it would return the number 0. And then the increment a number could be a function that gets the number instance, and then it returns that number instance after incrementing it. Like that self is here, you change the self and you return kind of a copy of the positive number. So when you call positive number, you get a copy of that positive number, and then all the functions can control what that data is. And here you would have kind of a similar thing where you create a positive number and return it, and then all the functions you would manually have to pass in the number, right? So if I have a create a number, then increment on number a, that's gonna return and override itself. So this is kind of the same behavior as this. Only you can see we have to do a lot of bookkeeping here, where we pass in the a and then we get the a back, and you know, this is a little more elegant and less error prone. So for of course. So for basic functionality, classes don't do that much, and that is why we've not used them so far, because we can do a lot of things that classes do with normal Python functions. But one thing that's nice about classes is that they not only have their internal data, and not only do they kind of group functions that belong together, because it's very clear that increment is a function relating to positive number, where in this snippet of code, that is not very clear. But they can also share functionality and get inherited. So we could create a regular number, and then between brackets say positive number. And this means that the number extends the positive number. And we can first just write past. It means don't do anything. And let's clean all the other stuff up a little bit. Or, well, let's just comment it out, I guess. It's maybe a little bit easier. It's going to make a new example. So everything below here is commented out. And then C is a regular number. C.increment will still exist because it extends the positive number. And then I can print C.number. And actually, I can also just print C, and you'll see that it is a number object. So it knows what class it is, and yeah, you can even find out what it extends and all that stuff. But this is kind of nice because now we could, well, we could change the init and maybe store more internal data or change the defaults of that data. But more importantly, we can add new functionality. So we can have a decrement function, and then self.number minus equals 1. Sorry. Yeah, so now our number can start at 0, go to 1 with increment, and go back to 0, or even -1 by decrementing it. So now we have a number that's allowed to make itself negative, and if you use the positive number, then that cannot happen. So this way you can write a lot of functionality that is sort of shared, and that's what Qt is built on top of. So you have the widget, which is this all-encompassing feature-rich element, which is just a empty square on your screen, right? It doesn't do anything yet. It's just a gray box, but it has all the logic for getting keyboard input, getting mouse input, being moved around the screen, showing, hiding, being laid out, having a layout. All that stuff is all handled in this base widget. And then Qt will actually give you a bunch of widgets that are based on the basic one. So if we continue here into Qt land and just import all that stuff real quick, then I could, instead of my numbers, I'm going to go down to the bottom and I'm going to make a custom class called, well, let's call it app, and that will be a Q main window. And then, so when you want to write an init function that is in a subclass, or a class that extends something that exists, then you have to write something like this called super, and then the name of your class, comma, self, and then another init, and then you call it. And what this does is it makes sure that the Q main window initialization function actually runs at this time. If we don't do this, then Q main window will not be allowed to set up its own internal data. And if we look at our numbers, if we were to create a init in the number class and don't call the parent, then we do not have a self.number to manipulate because it was never set up. So you always have to either don't write an init, or when you do, make sure to call that super. And that's why my IDE also makes this yellow background where it says, warning, you didn't call the super init in your init function, which is very convenient because Python doesn't always warn you about it, and you might find out later than you want. So now we have an app, and I can actually create a little Qt application as we did before. And instead of creating a Q main window, I can just create my app and show that. And if I run this, I get like this Q main window, but it's not a Q main window because it's running my code. And I can demonstrate that by going to self.setWindowTitle, which again, because we extend the Q main window, the self object in this case is a copy of a Q main window and can do all the usual stuff that we would normally do with a Q main window right inside of any of our functions, including the init, but any of the other functions that we might want to write as well. So we can say hello world, and just to show you, change window title, I can create a custom function that just changes the window title to by world. And then if we just create the window, it will say hello world. And then if I call this function change window title, then it will say by world. And that just goes to show that we can extend the existing Qt functionality with this application. Now in this next section, I'm gonna go back to the model and view system of Qt, but I really wanted to have you understand this setup, because going forward, I think it's this is the right way to write an application. And actually, I'll add a few more details. So I'll create a new Scratch file and just copy paste some of this stuff in there, where you just have a little bit of a more clean setup. And besides all the Qt stuff, I'm also going to import sys. And I'm not sure if I talked about this yet, but if you create a Q application, it takes this list of data. You can use sys.argv, argv, to pass in any command line flags that you pass into Python when you're launching Python, and forward it to Qt, which is kind of nice because in the Qt command line, you can change the style, for example. So maybe you could, I don't think they have it right now, but in the future, you might be able to enable dark mode or light mode of the UI, and you might want to do that in the command line. And by taking command line arguments using sys.argv, and forwarding it to Qt, all the usual Qt settings can still be controlled, even though you're writing the application and it's not like a Qt executable. We're using Python here. It will still work kind of as expected, and you're not losing this functionality there. Then the final thing that I also don't know if we've discussed this before, but if you write it like this, if double_name equals double_main as a string, then indent all your code. This really finishes up what you would consider a user-friendly module. So when you import something like sys doesn't run any code ever. And when you import my Scratch34 file without this, when you import the file, Python is just going to go through all of this code, and it will say, oh, this file adds this class and you can use this class now. But it also sees this code and will just run the code, and then this function, this app.exec function, will, it will halt the application, and Qt will do its thing and show the window. Until you close the window, Python will continue. You don't want that when you're importing a module, because your module might add additional features. Like when you're importing sys or Qt, it adds features. When you're importing Maya, it adds features. And if any of those imports would have a block inside of them, like this app.exec, suddenly when you're importing a file, your entire program just stops at the first line. So to avoid any unwanted code to run when you're not running this main file, but when you're just reusing the code in another file using import, you use this name equals main system. So when an import happens, this code doesn't run. When we run this file by right-click running it, or on the command line saying python.exe, run this specific file, only then this code will run. And that's very powerful, because you can write your code and add a way to test your code and debug it at the bottom. But then once your code is complete and it all works, you can just start using it in other files, and you can leave your test code there, just in the case in the future you need to debug something goes wrong. It's really nice to be able to store this code without having to comment it or delete it. Yeah, that's this is just a great template for a clean project setup where you're gonna create a Qt application. Then all the Qt widget creation would happen in the init function right here. All right, so with all that said, let's dive a little bit more into the Q file system model. Or well, I haven't mentioned that yet. I'm going to make a file browser. So a file browser is great because you have this tree of the folder structure, and then you can have a thumbnail view of all the files in a folder. And when you select a folder, it shows you which files are in the folder. And Qt actually has a great way to do that because you can create a Q file system model, and it will be able to look at the file system. And this is, yeah, it's just super convenient because now we don't have to make our own data set. We can just point at a folder on the computer and we have some data to test with, and we can just continue developing the UI. So I'm gonna set the window title to my first file browser, and I'm gonna add a widget called a QSplitter. And the QSplitter is basically, it's like a horizontal layout or a vertical layout. You have to actually specify the direction using qt.horizontal or qt.vertical. But what it does is if I open this project view here, the user can adjust the two widgets. So it's a customizable layout. That's how you can think about it. And I'm going to call set central widget so that the splitter is actually attached to the main window. And then, why is this giving a warning? Oh, set central widget. It's hard to type and talk at the same time sometimes. Set root path. And I'm just going to point to this project that I'm working on. It's just a little hobby project. And it's a great way to look at some files. So there we go. The file system model will normally just look at the C drive, or maybe not even work until you set a root path. So it's important to point it to a path that it will start working in. Strangely enough, when you do this, you also need to set the view to use the same root path, because else the view will just show the C drive for some reason. So you need to set the path, and then also you need to set the view to look at the right root. So when we create a view, I'm going to create a Q3 view, which is a little thing, a little bit like this, right? You have expandable folders and files. And then I'm going to set treeview.setModel and treeview.setRootIndex. So the view is going to be displaying this data model, which is a file system, and then the view will have to start displaying at this specific index. And you can just get the model.index and then you give it a file path, and that way yeah, it will have the same root as the model intended it to have. I think you could even do model.rootPath. Yes, so you're only writing it once and then you get it back, get the index, feed it into the view, all that stuff. Now let's add that to the splitter so that we can actually see it. And yeah, let's just give that a quick test run. Horizontal. Cool. So this is a tree view of a file system model which matches our project, or my hobby project. So that's kind of cool. Then it had a few extra columns in there, which I'm going to show you. You can hide that. Set column hidden on the tree view, and then you can just say, you know, don't display the other three columns. So now it's just a list of files. Instead of having the size and the date modified, you just have the name, which is nice. Then I'm going to create a thumbnail view, which is called a QListView, because by default it actually just shows a list of files or items. It can be any kind of data if you're not using a file system model. But you can customize it to be an icon-based view, and that's really cool. So the list view is where you can change from a list into sort of this grid-based thumbnail display. And it will also need to look at the same model. So this is where what I've been hyped about all this time. We have two different views on the same data, and it's just it's super powerful because you can Also, later on, we can add editing functionality, and you can see when you change it in one place, the other place will just immediately show those changes. And that's, if you have to do that yourself, it's a lot of programming, and it's just handled for you for free, which I think is great. So we can set the view mode to be QListView.item mode, and now it's going to look more like a thumbnail view. Actually, I'll just show you without first. And for the thumbnail view to be able to display anything, we need to set the root index. But instead of just getting this and showing the same files, I'm going to immediately do something clever. So the tree view has a selection model. Let me comment this stuff out real quick. So when you click on stuff, that is handled in the selection model. So we have the data model, which is the files that we're looking at. The data model might be shared between multiple views. And then we have the selection model, and the selection model is every view has its own selection. So if I click on something here, it will not be selected in all the other views. And that's kind of important. So we get the model selection from the view directly. And it has this callback called current changed. And so when you click on an item, that's the highlighted item, that's called the current item. And when you change which one you click on, you can catch the index of what was just clicked on. So we connect that directly to thumbnail view.setRootIndex. And then let's add the thumbnail view to the splitter as well. Keep that group together. Whoops. All right, so if I click on this folder, I get all this stuff. And if I click on this folder, I get all this stuff. So when I click, it says, selection model, current changed, because you changed what is highlighted. And then that gets forwarded to the set root index call immediately of this view. So this view will just start looking at this folder. And because this is a tree view, I have these arrows here. And because this is a list view, I don't. So I can dive in deeper on this side, but I cannot dive in deeper on this view. So if there's a folder here, I can't double click it. I can't do anything with it. It's just displaying the contents of one folder. So now let's go into icon mode. That looks, well, not exactly like you might expect. And icon mode has a few issues by default. At least some settings are just not very nice. So of course, anything is customizable, but when it starts up, it lays out by text size instead of just giving everything the same size, which is not very nice to look at for the human eye. It's hard to find stuff here. It doesn't deal with resizing, like it just doesn't move these items to be on one row when the width changes. And things are movable, which is just really strange. So I'm gonna change all of these settings in the thumbnail view. Set grid size, so that will make everything just nice square icons. Then I'm gonna say set movement QListView.static, and that will just make sure that we can no longer like drag these things around. So I find that very important, because if you accidentally move it, it's just so confusing to look at. And then finally we have set resize mode, which is adjust. So now you can see these guys change their layout. We can select them and move them. We can click on these folders and see in a different part of the model. But again, this is always the same data model. So if we were to enable editing, we could rename a file here and you would see it show up over here, or the other way around. So I don't have editing enabled because I don't want to mess with my beautiful file structure here. But if you do enable that, you could like press F2 or enter or double click, and you could type a new name. And you would see if you change this name here, immediately this word will also change, because it's sharing the data. And when you change the data on one side, it will tell all the views like, hey, I've changed, and all the views will update and display the latest information. And that is really powerful for about anything you can do. If you're dealing with with image editing, you might have different views like a histogram and a thumbnail size and a zoomed in view, and all of those could just use the same data, right? It could look at the same image. And if you're dealing with any kind of layout structure where you're parenting items, maybe you're making a little layout app where you have to group elements visually. You could have a scene view where you move your items around and you could group them. You could still have a tree view that shows you the groups, or a layer view that shows you different layers of objects that are paired together and that you can hide and unhide, and you can see that reflected in your main view. So this is really just one example of what you can do with the model and the view system. And there, Qt has a ton of more stuff to offer. There's something called a proxy model. So instead of looking at a model directly, you put a model in between, which, for example, could filter out all the files here, so we could only see folders. And there's something called an item delegate. So when you start editing data, normally you have a text editor. If you want numeric data, you could say, I want to change the behavior without rewriting the whole view and all the editing functionality. You just say, instead of having a normal line edit, use a spin box, and now you can only type numbers. And there's just so much convenience tied into this whole system that it's really worthwhile to explore, because when you're developing applications, you're often dealing with a bunch of data, and this is really a foundation that can save you so much time. If you fit your problem to a model view system, then Qt can solve a lot of your work for you. With that monologue, I'll leave it at this. I hope it was a cool demonstration, and I'm sure I'll make some more to follow up on this and show you even more features. Thank you for watching.